Now, uniform distribution. You remember the figure I showed you, right? I have a grid. It's basically the top is the highest possible value you can get. The bottom is the lowest possible value you can get. They have different chance. Because to get this one, I need to keep winning. To get this one, I need to keep losing. But if I want to have this one, easier. I can either go from here to here, or I can go like this, or I can go like this. So basically, I have many ways I can go to here. This is actually what? This is actually, let's say I have how many n, and then this is how many win is k, then this number is actually n choose k. This is exactly binomial thing. So different number have different probability, and their probability is scaled by the binomial coefficient n choose k, right? And if you remember the Pascal triangle, usually the number in the middle are the highest, are the largest. Well, because you have so many, the number of ways to reach the middle is the highest. So that's why those numbers, you remember 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, the middle number is always the largest. Because that means you have 6 ways to reach what? 1 win, 2 win, 3 win among this number of n. So that's the idea. What about uniform? Uniform is very simple. I don't give a shit on this. All of them have equal chance. So it's not even this kind of figure. It's just saying that I have n outcome and all the probability is the same. So suppose I have upper bound B and lower bound A. What does it mean? It means I have a value can be any value between A and B, and that's it. So it will be A plus 1, A plus 2, A plus 3 up to B. And all of them have equal chance. N number of them, so 1 over n. That's it. Then what's the expected value? The expected value is the middle point of A and B, so this. What's the variance? Okay, if you want to know this, try by yourself. Use the formula, you will get this number. Then here's another example. You have a fair die. What's fair die? The 6-sided die, 7-sided die, 8-sided die. Now you see all the dice. That means 1-sided, 2-sided, 3-sided, 4-sided. Okay, there's no 1-sided. Okay, 6-sided. You have 1, 2, 3, 4, 5, 6. All of them have equal chance. So all the die actually are uniform. So if I have a 6-sided die, what's the expected value? You do what? What is Ex? All the possible value of small x you can have, multiply the corresponding probability. So for 6-sided die, you'll be, what are these x? 1, 2, 3, 4, 5, 6. What is the p? All of them 1 over 6. So 1 times 1 over 6 plus 2 times 1 over 6 plus until the end, you get 3.5. You do so many calculations. Or you use this formula, it's the same. So that's why we sometimes want to have formula. That's why we will say, okay, what's the variance of the binomial random variable? If you don't know the formula, okay, you can do it by hand. Doing the definition, very tedious. So you have two sorts. Which one is better? And here's the thing. This kind of number actually is uniform distribution. So let's talk about them one by one. So suppose you have a big dude sword, okay, and your sword have physical damage, just number, okay, 10 to 41. That means what? It's a uniform distribution between 10 and 41. That means it can take all the possible value, 10, 11, 12, blah, 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 until 41. And then what? I ignore the attack per second. Doesn't matter. So if X is like damage deal per second, then actually X is a random variable between 10 and 41. So what's the expected value? Oh, it's just this thing. A plus B divided by 2. And also have the variance. Okay? So expected value is 25.5. That means what? That means, let's say you take this weapon as your weapon. And then you go to play game. On average, every time you hit, you deal 25.5 damage. That's it. What about the variance? The variance is 85.25. This is a big number. Okay? So that means what? That means the variability is very high. Sometimes you get 10, sometimes you get 41. Not good. You want consistency. So big variance means not so consistent. Small variance means consistent. What is the most consistent weapon? The most consistent weapon in this case is this is not a range. It's exactly 25.5. Then if I have a weapon, this number have no range, only one number, then this thing have variance 0. Why variance 0? What's V? E of what? X minus EX. Okay? And then this whole thing square, right? Why I'm saying this guy have variance 0? Because this thing, what does it mean? It means all the possible x, I subtract the average and then take the square and then take this thing as a random variable and take the expected value. If this is the only value I have, then this is 25.5 and the average of this cell is 25.5. So this guy is 0. So E whatever 0 is 0. So that's why V is 0. Okay? So this is the thing. Now let's go back to this weapon. This is a weapon with this physical damage and then attack per second. And then this is a critical strike chance, and then every first strike deal triple damage. Let's ignore this triple damage for a moment. Let's say critical strike means double damage. Okay, then critical strike means double damage means what? Then you turn this thing into this thing. What is this? It's a random variable. What's the random variable? This is a random variable Z, okay, of what? You either go top or go bottom. You go top with a 92% chance. You go bottom with an 8% chance. And then what's it here? It's also a random variable. What random variable? U this thing. So you have a random variable U1. And below you have another random variable U2. Now you see, this looks familiar, right? This is exactly this thing. And your goal is to calculate this thing. Now you see this slide is not I make up for bullshit. It's useful. At least for playing computer game. So what? You want to find the E of this guy and you want to find the E of this guy. Then you find the E of this guy, you find the ultimate damage output of this sort. Not taking care of this, but later. So now I have this two. So I have what? What's the EZ? EZ will be the value here, 0.92, plus the value here, 0.08. Except what I'm doing here. Okay? What is this thing? This is the random variable. What random? Uniform random. First one. What is this? Uniform random. This. Then the E of this thing is formula. A plus B divided by 2. A plus B divided by 2. So you get 15 point something. That means what? If the last line I don't care, this sort is rubbish. Because this is 25.5. But this sort is 15. So I should throw away. But now, let's talk about this one. This says every third time you deal triple damage. That means what? This value is ignoring the last sentence. Have a 15, then that means, let's say 15. I don't care about decimal places. That means if I care about this, it's just 15, 15, 45 divided by 3. So this sort actually 25. So that means what? That means slightly worse than this big dude sort. This one is 25. This one is 25.5. Okay, by looking at the number, this is better, this is rubbish. But you can calculate the variance. I can tell you this one, the variance is lower. Then this one actually is more consistent. And then you may then say, okay, now they have very similar expected value. This one is variance is smaller, so I should take this one. For this module, yes. But what about real gaming? Real gaming, this is not a complete story. It also depending on what you are hitting. If the monster have many high HP, many high health point, then actually you should pick this one. And if your monster have very low HP point, you should pick this one. But that's other story. And in this case, you have two random variables interact with each other, and you need to consider what happened from both the attack side and the defending side, which is complicated. So now, by learning what is uniform distribution, now you have a scientific way to pick weapon. What about armor? What about magic wand? Same. Then what's next? Geometric distribution. Oh my gosh, so many symbols. No, it's very easy. It's just you gaming K time, you fail over every time until the last time. That's it. Or you do some mobile game, pull some stuff, and then you fail the first 99 times and you win the last time. Something like that. Okay? Then that's exactly called geometric distribution. In mobile games, sometimes they say, oh no, every 200 pull, one guaranteed. Then you do this. You do this. This is exactly the same thing. But let's ignore those. So what does it mean? This means you fail for all the first K minus 1 time, and you success only in the last. Remember, this means success, this means fail. Phone call, you need to call somebody, let's say fix the internet. You call the company, and the company staff don't take your call, and then you bomb their company phone number, and you bomb them K time. And all the first K minus 1 time fail until the last time you win actually is this. So that means if you know the theta, you can calculate all this probability. You call them 10 times. What's the probability? You call them 10 times, 9 times fail, only the last time success, and then you will have a number. And then you can also do the following, like you call them 7 times. The first 6 times fail, last time success. Then you have another number. Then you compare these two numbers, you will see which event is more likely. If the chance they get it is 0.5, you won't see this kind of thing. You call them 2,000 times, and the first 1999 is fail, and then you get the call in the end. No. Then you will want to know, what the heck is the expected value? That means on average, what you see, it will be what? Exactly 1 over theta. And here's funny thing. That means what? If the call is fair, That means the chance is 0.5. What's the expected number of calls you need to call a company such that somebody answer you? It will be 2. Just do this calculation out. So this thing is this thing, right? Then what is the P thing? P thing is basically this expression, right? So I copy this expression here. Okay, and then what? This is what? This is on K. This guy have no K. I take it out. So I put the theta here. Now I have this expression. Now here's a what the fuck moment. Do you remember this? 1 plus 2x plus 3x squared plus is this thing d 1 over 1 minus x. I have talked about this in combinatorics. What the heck is this? This is 1x power 1 smaller, 2x power 1 smaller, 3x power 1 smaller. So this thing is exactly this underlined thing. So therefore I have this thing. So therefore, yes. If you don't see this, doesn't matter. I'm not going to ask you to prove this kind of thing. As I said, this thing belongs to combinatorics. Probability, I'm not going to make it crazy. And then what about variance? Variance, you have this, right? So then you need to find what is Ex squared. Ex squared is k squared, the pk. Theta have no k, I take it out, so I need to do this. And because of the same reason, I can differentiate again, right? So I differentiate, so you take this whole expression, I d it one more time, then I get this. So therefore, this thing becomes this thing. And I simplify, I get this funny expression. Example. So suppose I have a fair coin, 0.5. I flip a coin 1 time and success at the first time, then 0.5, right? Because the successful rate is 0.5. Easy. So exactly is this. Nothing changed. What about if I flip 2 times and I fail the first time, success the second time? You don't need to even use geometric distribution. It's fail times success. So 0.5 times 0.5. So 0.25. But this is the formula. You can do it. And then what about if you have this? So all the possible outcome of 2 toss, you have what? Fail, 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 success, success, fail, success, success. Here is what? Toss 2 times. Only success in the end. So only success in the end is this case. This case, classical probability, event size is 1, sample space is 4, so it's also 1/4. So I have 3 ways to find the same thing. This is simple, but if I do this, you flip 20 times, all the first 19 fail, and only the last thing you success, then you do this. Then you also need to remember why there's no binomial coefficient before. There actually is a binomial coefficient before. So you can think of this actually have a binomial here, but I just hide it. Okay? And what is this number? This is 0.5 power 20 times. So it's a very, very small number. So it means what? Actually, this is also a life lesson. Keep failing is very unlikely. I'm not religious, but I believe in probability God. And because probability governs everything, even physics, so this is God. God say this, okay, then this is true. So now, another one. Negative binomial. Okay, just a fancy name. What's the negative mean? Binomial means n trial case success. Now we talk about fail. So success is positive, fail is negative. That's why negative. That's it. So we're talking about out of n IID ballooning trial, exactly k fail. K fail, not success. So negative. So we do this. What is this? N choose k with repetition. Number of ways to achieve k fails in n trial. And the order matters. Okay? I'm going to explain it soon. Probably this kind of thing with repetition is the most confusing one. Okay? And then we also have EK and VK. Not going to talk about what's EK, VK here. Again, I'm not going to test you. Then you may wonder, isn't fail just the opposite of success? Why can't I just use this as binomial? Because they are different. What's the difference between binomial and negative binomial? What's the same thing? What's the different thing? The same thing is both are about independent ballooning trial. Okay, I call it IBT, okay? So we have 2 numbers, both have 2 numbers, NK. Both of them have NK. Both of them are ballooning. Okay, then what is different? Binomial is you fix N. So that means what? I start with 10 flip. This 10 is given. I know 10. And I want to look for the probability of something happen. So suppose I flip 10 coin. This 10 I know already. And I want to know if I flip 10 coin, what's the probability I get 7 success? So I'm asking the question, what's the probability 7 success? What's negative? I fix K. It's not n. So it's the opposite. It's like I flip coin, I want 7 success. So the 7 is given. And I want to ask, if I want 7 success or 7 fail, what's the probability I will get this if I have 10 flip? So it's opposite. So that's why it's called negative. So the idea is, binomial means I flip 10, 10 is given, ask probability 7 success. The negative is, given 7 success, what's the probability I need to flip 10 times? Because for 7 success, I can also get it in 7 flip, right? I'm very lucky. I flip 7 times, all of them success. Then there will be a probability, right? But now I'm considering, I don't know how many times I need to flip. I am just asking, I know, given the condition, I have 7 success. What's the probability? What? I need 10 flip. Because 7 success can mean 7 flip, 9 flip, 14 flip. Because for 7 success, I can actually need what? 2 million flip. Due to some very unlucky reason, I need 2 million flip, and all of them fail until some of them 7 success. So that's why these two things are different. You need to understand this meaning. Once you understand this meaning, then you know why this is repetition. Because you allow not success to repeatedly happen. This is not the same. So therefore, on this is different. If I am talking about toss coin, but you can think of you have two things. Think of it as nature or probability God. Okay? If you talk about binomial, the nature say that the nature toss 6 times for you. You cannot control this 6. The nature toss for you. And you want to know the probability getting forehead. What about negative binomial? The nature do not toss 6 times. The nature will tell you 4 success. And you want to know what's the probability if you need 6 times to get 4 success. Get 4 success can be 5 toss, 7 toss, 2,000 toss, 2 trillion toss, right? So it's different from this one. This one, both 6 and 4 are like fixed, but this one is not. Okay? So that's why it's different. And also, you may remember, this number, if k is not 1, is always larger than this number. Okay? In the quiz, I asked you this question, right? If k is not 1. Why? Because for asking the question, I want 4 success, it's possible I need 2 million toss. So I have to count more stuff than this one. So therefore, this is larger than this. Okay? So here's an example. Suppose fair coin. What's the probability you need for, you want 4 success. This is given. You ask, what's the chance? You need to toss 6 times. Then you get this number. And the same thing. Find the probability. At least 4 fail or 4 success. Then you have some rule. You repeat this for 3 cases. And you see this is quite low. I'm telling you, if I change this question to, if I need 4 success and then or 4 fail, and I ask, what's the probability for 61 toss? Then I replace this by 61. Okay? And then you will get a very, very small number. The life lesson is, keep failing is actually very unlikely. Therefore, work hard is useful. Okay? And you cannot argue this with probability God. It's always true. Okay? So, I will skip it Friday. Now let's look at this funny picture. So this is the relationship. Uniform just alone. We have baloney. A bunch of baloney add together is binomial. From 2 things to 3 things, 4 things, 5 things, we have multinomial. Geometric means fail, 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 fail. This means success, success, success. So that's why it's the opposite case. Many geometric is negative binomial. And then you can also have negative multinomial. Yes. So that means what? I didn't talk about it even in the combinatoric. You can have this. N choose K1, K2 with repetition. No, 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 no. Then what? Here's the funny thing. If you do N very big, you actually get Poisson distribution. And if your N is so big that almost infinity, you get Gaussian distribution. And this is central limit theorem. And don't worry, this part we don't care. And that's it. Then you may know, oh, there are also beta distribution, gamma distribution, Wilbur distribution, so many people's name distribution. I don't care, don't worry care. This picture, I would say, this one, this one, this one, and this one is enough for 99% probability for the distribution. 99,999,99999, not 1, but very close to 1, is just this one. So that's the whole picture. So what is the useful for Poisson? This is not in exam. I just tell you what happened. So you do something called maximum likelihood estimation. You can actually know what's the probability you will get a bus after 10 days. Here I use COVID. So anyway, I'll do this Friday. So let me recap. What is this part? This part have nothing new. This part is just combinatorics improbability. So nothing new. The only thing that is new in the whole slide, in everything here, is just this slide. This is the only thing that is new. Not just, but also some name. What is marginal? What is joint? What is conditional? What is independent? And a bunch of bin unigio net bin poa. It's just names. And that's it. So that's everything. And let me recap. Probability in exam, exactly this. That's it. I'm not going to ask you crazy combinatorics problem to variance. If this slide is like this and it's like this. Yeah. The part that is hard will be coming from combinatorics. Okay. That's all. See you Friday.